Now we introduce the Wronskian formula, which is usually used to check for the dependence or independence of two solutions obtained from a differential equation. So before writing the linear combination of such solutions like y1 and y2 in this form, we have to check the independence by using this formula. Obviously, this formula has an answer of not zero. The finite answer we have of not zero, finite and not zero, shows the linear independence of the two solutions, where they can be written in this way. Here, y1, the product of the first solution and the derivative of second solution minus the product of the derivative of first solution by the second solution must not equal zero. We're going to apply this formula to our solution of jp and j minus p when p is non-integral. So applying that, we should get an answer like this, where ap equal minus 2 sine p pi over pi. Well, to prove last formula in equation 4, quoting the expression of the Bessel function, the factorial form this way, and we expand it by taking the first two terms in this way, and also the expression of j minus p, and expand by retaining the first two terms in the expansion. Now, if we consider the first terms of the expansions in equation 6, this one, and equation 8, this one only, and we'll take the derivative of the first one to be that one, and the second one, j minus p, the derivative of it is this one, equation 10. Now, combining what we obtain in equations 9 and 10 and substituting that into equation 3, we're going to get on the right hand side of this. Okay, by applying the identity of the factorials as related to the gamma function, p factorial, the product of p factorial and minus p factorial is equal to p gamma of minus p, and applying the identity of gamma of p, the product of gamma of p by gamma of 1 minus p equals pi over sine p pi. Using these two relations in equations 12 and 3 into equation 11, we'll get the final answer as this, and that's what we want to prove. From this, we can conclude that the constant AP is actually a criteria for the independence of the two solutions. Because when we put p as an integer, we get an answer of 0. This means that in case we have an integer instead of non-integer, we don't have any linear independence anymore. So both jp and j minus p is going to be dependent on each other.